What is up, guys? We are back with a brand new sound device. I'm here with my friend, co-host, DIY guru, Justin, the DIY audio guy. How's it going, Justin?
Greetings. I am well. How are you?
Greetings. Yeah, I was just watching a show that was literally just about in Roswell, New Mexico, and so greetings just reminds me of like the little green men. Oh, you want to hear something really funny? Actually,
Yes,
we
I do
were.
actually.
I had to do a background check recently for something, and it asked me if I was an illegal alien. And my son is next to me, who's like 6 at the time, and he's like, "Why are they asking you if you're an alien, Dad?" And I was like, "No, not an alien," because he was thinking, green men. It was so
Yeah,
funny.
that's yeah. Background checks. Well, hope you passed the background check, Nick.
Yeah, I did. Hello from inside the camper. Who said that? I hear voices. So Robbie is in his camper today. We got David K here, and we got El Fuego. Oh, true voice of reason. Good to see you guys. Happy Monday indeed. And why is it Happy Monday? Because today we're going to be talking about something that I think a lot of you guys want to hear about, which is testing. How do we test accurately amplifiers for like wattage output? How do we test speakers for the actual impedance? And how do we test for their frequency response, subwoofer, all that type of stuff? Where are they actually being ported to? What is the tuning frequency? Those things. We're all going to talk about that. I've always been suspicious, says Brian. I think he's talking about aliens, and he's probably right. Good, Nate. We got Brian Steele and Colby Laro here as well, and Brian Rollerson. So, all right, guys. So, me and Justin have been doing this YouTube thingy for a little while now. And Justin, you've dynoed a few amplifiers in your time.
Yes, I have. Just a handful.
Yeah, and I started doing that as well. And you've also tested a couple speakers as well, right?
Yes.
So today we're going to be talking about what are the tools that people need. And I think we should start by saying that testing equipment in general can be a wide range of things. Don't you agree?
No, I'm going to
price.
disagree.
Okay.
No, I'm going to disagree.
Well, tell me what you mean.
I'm going to disagree. So, it is my opinion that if you don't go out and buy one of the really expensive SMD 81 amp dynos like Big B uses, like Five Star Car Stereo has, if you don't run out and buy one of those, you should never even go near an amplifier. You shouldn't be allowed to. And if you want to be really serious, what you really need is I'm blanking on what it's called, an audio precision. So
audio precision.
The AD1 is for, let's just be honest, it's for the low class people who just want to see the power of an amplifier. And that's the bare minimum if you want to test things. If you really care about testing things, you should go buy a Klippel and an audio precision. Those two things will set you back probably about $150,000 or $160,000, which is child's play if you're serious about audio.
Audio precision's about 50 grand, I think, and the Klippel's about
Are they 50 grand really? I don't know what they are. They don't price them on their website. There's a call for a quote on their website. So I was curious one day and looked them up. So they won't even tell you.
No, they don't. Well, and my understanding is the highest end one is somewhere in that range. And I think Aaron has a Klippel, and Aaron's Klippel I don't even think is the highest end Klippel, and his was like 100 grand. So, obviously there's a wide range of these things. We can start you off testing for a couple $100, maybe even less. Or you can go like with this, the 81, which tests amplifier dyno, does pretty much a lot of the work for you. But $3,654 and 3 to 4 month lead time.
And Keaton has got some crying, laughing emojis. Yes, obviously I'm joking. I hope that's obvious. Brian Rollerson says, if you aren't a peasant, you'd buy 2 each.
Buy 2. Yeah.
Thing is,
Brian is one of my patrons. So Brian, since you are not a peasant, I would love for you to send one to me. No, and I love what El Nufo says, because he says, hey, just having high-end gear does not mean that one knows how to operate it properly. And that's true. And here's the other issue. I was on Facebook group the other day, and someone posted this little amplifier. It looked kind of like a Lapai 2020. And I was going to ask Justin a question about that, but he disappeared, so I'll wait for a minute. But
I'm still here. Go ahead. I just hit mute for a
oh,
second.
are you familiar with the little Lapai 2020 little amplifier?
Yeah, yes, I have. I think I've got, if not one that's very similar to it sitting around the house.
Well, I think Big D tested that a while ago. It was like 7.5 watts, and we're going to tell you how to do that here in a minute. Well, this looked very similar to a 12-volt system. No way it did 36 amps. And they were claiming it to be 400 watts, 200 watts by 200 watts. And I'm like, and this guy's like, I want to buy this because it's a 400 watt amplifier. And I'm like, dude, you are not getting 400 watts out of this. And yeah, Kinter amp is one of those, like, and guys, here's the deal. Like, we need to know how to do this. So the first thing we want to talk about is, before we do into amplifier testing, is how to know, first of all, if anyone's even BSing you without test equipment. Justin,
yes.
Do you know if someone's BSing you, or how can you
look at Annihilation Industries for a second there? Put his comment up. God forbid we don't use tools you could technically get at Harbor Freight and Amazon and a calculator and do a little bit of math and a little critical thinking. God forbid, right? And so this is important. Someone commented on one of my videos just this week, and they were looking for advice. They wanted to add a second 12-inch subwoofer to their system, and they were running a 1,000-watt amplifier and 10-gauge power wire. That's speaker wire. Oh, right. Now, so 10-gauge power wire. It's like, I hate to break it to you, buddy, but if you're running 10-gauge power wire to your 1,000-watt amplifier, you're popping fuses and you're lighting fires in the car. And that, I think, is your point. You can eyeball this stuff without any test equipment when you're shopping for gear. Yeah, and it is, like Annihilation Industry said, it's math. Just do some very simple math. And so, shout out to Big D Wiz, Wilson Audio Labs. Absolutely. He calls it the big dummy math for a car amplifier. You look at the fuse, multiply by 10. Now, when I say that in YouTube comments, that's or a great Facebook, point. Someone always gets on me and says, "Oh, you can't do that because you're 14 volts." And it's like, yeah, but after you figure the efficiency and the voltage and the amperage, so let's take the fuse, multiply by 10 will get you in the zone to know if someone's just, lying to you off the charts full of crap.
Let's break that down for a minute. Okay, so what we're talking about here is amps times. What we're talking about is how you figure out watts.
I'm going to grab a prop real quick while you do that. So you talk and I'll grab a prop.
Watts are quite simply, the equation to get watts are amps times volts times efficiency, technically. So basically, if we had a 12-volt system, so like a car, and we know that it can only put out 10 amps because that's how big the fuse is on the back of the amplifier, then you know that that's max 120 volts. Unfortunately, we also have to take into efficiency, and no amplifier is 100% efficient. So, 80% efficient, something like that. So you'd be closer to 100 watts. So the first thing that you do is take a look at your car amplifier. Before you do anything, before you buy any of the testing equipment that we're going to show you in a little bit, you can easily just take whatever fuse is on the back. If there's only one 25-watt fuse, just go to your calculator and just do 25 times 12. And after efficiency, 25 amp fuse. You're right. 25 amps times 12 is about 300 watts. It's not going to get any more than 300 watts, period. So if they tell you it's a 600 or 800 watt amplifier, no, you're getting 300 watts max. Now, also, before we go too much further with your prop, with a home amplifier, you often get an external power supply. And that external power supply, is that what you have? You're muted, bud. You're muted, Justin.
I'm grabbing a home amplifier. Okay. This is, you recognize this one? This is the
Dayton Audio 2.1.
Yeah. And so it can handle up to 24 volts DC. I'm reading right off the back, 24 volts DC. And I think it comes with a 3-amp power supply. Maybe a 4 or 5 amp.
So let's do some math right there. 24 times 3 is 72 watts.
Yes. but Dayton Audio claims this is 200.
So we can already do math and tell BS right off the bat. So you don't even need testing equipment. This, for example, is actually a power supply for one of my lights, but this is a 12 volt, 5 amp power supply. So we know if this was plugged up to an amplifier, no matter what the amplifier said it's capable of, 60 watts. Now, the reason why a lot of amplifier manufacturers are dishonest is because of one thing. When you buy a chip, most of these are chip amps. So if you buy a chip off Texas Instruments, you buy a chip off of Infineon, or whoever you buy your chip from, they'll come with a spec sheet, and that spec sheet will tell you what it's capable of. And almost every manufacturer of these little amps will post what the spec sheet says, not necessarily what their particular amp topology and power supply is actually capable of. So there's a concern there. So always look at what the power supply comes with, and then multiply wattage and voltage. Now, I just did a video with a Burson Audio where I just tested that. So if you guys want to see that, you can. And Justin, you have done some. Here's one that you did.
So this is an example of what we're talking about here. Those fuses are green. And do you know what the color coding is for the fuses?
Man, I do not. I think those are 25 watt fuses, or 25 amp fuses, right?
30 amp 30 amp
30.
fuses.
Okay, 30.
And there are different shades of green. And so any guess what amplifier this is? Some of y'all might be able to see it. So it perfectly fine looking little amplifier, and you might be able to tell by looking at it.
Yeah.
Right. So Boss had on the box on this thing. This is what I was going to grab. This is the prop I was going to grab. Then I realized it was out in the garage. Has 3,000 written all over this thing.
It says it right there on the corner.
Right. Until you get into the owner's manual, it appears to be a 3,000 watt amplifier, and there are stats in the in the box in the owner's manual to give a little bit better look. Any idea what this thing did power wise?
Well, it's max 600 watts, but I'm going to guess after efficiency, maybe 500 total. Oh,
let's see if I have
even
the
worse.
Oh,
was that not
this
it?
Was
394?
This was at 2 ohms. I don't think I have a screen grab.
Oh,
so at 4 ohms, it was doing 223. And
wait, is that 223 per channel? Is it a 2-channel amp, or is
it's a mono amp?
It's a mono. Okay.
Right. And I don't think I have a screen grab of the final power, but it was something like 560.
Yeah.
Yeah.
So we can easily tell just by looking at fuses or looking at your power supply where you should be. And you're right, 25. So 10 times 60, which is, you said 230, is around 600. It got you right around there. It was less, but right around there.
It's a solid 550 watt amplifier that's priced like a 800 watt amplifier and advertised like a 3,000 watt amplifier.
So here's the deal. True Voice Reason. I want to hear your thoughts on the Burson video later. So I did just review a Burson audio amplifier, which was a little confusing. And I'm going to get this out in the open because on their website it says 45 watt amplifier, but then it says 45 W and then space PC amplifier, which typically means watts per channel. And then everywhere else you look for sales says watts per channel, 45 watts per channel, 45. So Amazon, there's headphones, whatever. All these other places.
Wait, WPC, that would be a 45 watt amplifier for your computer. It's a PC amplifier.
I think that's what they're trying to say, and everyone else has taken it out of scope. But I can't tell. But it is so confusing. It is definitely either really good marketing or really poor marketing on their part. And Travis Reason is right. Class B are different beasts than Class D. And there's also the fact with Class A, B also being, not efficient, not as efficient. So let's talk about some of the things you might want to measure an amplifier, car, or home amplifier with. And this is one of the things you need, right?
Yes, I think that this is the Lumi was the brand name forever, but the brand name has changed. What's your brand name?
Well, it's the LM 2020, and it's something I can't pronounce. So, but it's an oscilloscope. You have one with you as well.
Mine is also an LM 2020. But what's your name? Put it on the camera so I can see the name.
It's like, you know what? My light's not over there, so you can't. There it is. It's BS
It's
plus.
it's picking up a waveform, Nick. I couldn't help but notice that there's some power coursing through the air nearby you. You're like Thor or
It's
something.
me. It's me. It's me. It's me. So we're gonna talk to you about this. But one of the things that I find interesting is when you're testing an amplifier, what kind of current is in a vehicle,
Oh, this is so funny because
right? Because
I
this is the confusing part of testing, isn't it? For a lot of people.
it's not confusing to me. But okay, cars run on, well, okay, cars generate their power with an alternator. Why do they call it an alternator?
Alternates current.
Right. It generates alternating current. So your car runs on AC, but the alternator converts it to DC. And so the car itself, everything past the alternator is a 12 to 14 volt DC system. So obviously you want to set your multimeter to voltage DC when testing your amplifier output, right?
That's what you would think, but it is AC voltage. And that's the part that I think confuses a lot of people. So when you have one of these, so for this particular thing, like if we look at the unit itself, it has a V and then what do you call that squiggly line?
A tilde.
For a tilde. Yeah, it has a tilde there. A tilde.
Some people call it a twiddle.
And you see, we see AC voltage. And for this, we just hold down R. And when we hold down R, that turns it into the oscilloscope portion of this.
Now, one thing to remember, yours is probably the same as mine. It's auto ranging, except when it's in oscilloscope mode.
Yeah,
So if it's in oscilloscope mode, you start turning the volume up and down to measure the voltage. It's going to go off the screen. So you got to go into these buttons, and I'm not sure how they work. I just punch them until it works.
Yeah, the time and the range are the main things that you need to go into and change that until you get something visible. And the reason why you need an oscilloscope is because of this. When power is going through your amplifier and it's clean, it'll have a really nice, it's like this. When you're looking at someone to date, you often look for all the right curves and you don't want flat in certain spots. And that's the same with an oscilloscope. An oscilloscope, you want the curves in the right areas, but as soon as those curves start to flatten out, we have what we call clipping. And that means we no longer are getting good, clean power out of this. Instead, we're getting dirty power that can damage our equipment. So the oscilloscope is there for us to determine when that good power ends. Is that a good way
like
to
that analogy. That's a great analogy. You don't want you want all the curves in the right places. You don't want things flattened off.
Yeah, I agree. And I want to talk to True Voice of Regions thing. And he's right. The WPC space does make a difference, but different fonts make it look different on whether there's a space or not. And the way it's on their website, you'd have to look at it. You can't really tell if there's a space or not. I think there definitely is in their website. But the problem is everywhere else that they've advertised it, they've put watts per channel. So it's one of those things that, and they've never broken it down on their website. So it's one of those things that there's definitely enough confusion out there that I think that they should take time to clarify. So
I'm searching for a file with a. I'm looking right now through my computer to see if I have any footage of the scope going.
Let's talk about the setup of the scope first before we do.
Yeah,
this.
go ahead.
Let's assume we're doing a 2-channel amplifier. What we're going to do is we're going to clip these onto one output, speaker wire output of the amplifier. And the other also needs to be hooked up. And here's the reason why. So if we're doing like a 4 ohm load, you need to hook up these. These are called dummy loads. These are just resistors. They're 4 ohm resistors. Okay. If you were testing 8 ohm, you would need 8 ohm or 2 of these in series to get 8 ohm. But you need to hook one up on both sides of the amplifier, both the left and right side. If not, your readings will be incorrect. You have to load both sides.
All channels must be loaded.
All channels must be loaded. So having said that, you need to plug these up to both the left and right side. So you're going to hook these up. I like to use like just little alligator clips. It doesn't really matter, just to clip them onto the wires or whatever. It doesn't really matter. You can use speaker wire. You can use all kinds. You use whatever you want to clip these up. And then on one side of the amplifier, you're going to have the oscilloscope going, and it's going to go just like this. There'll be a red going on one side, a black going on the other side, right? Just like that. It'll be clipped together. It's that simple. And the oscilloscope, you're going to just keep turning the volume up until you start seeing the waveform clipped. And once again, it'll be that nice, beautiful curve until it's no longer. Once it starts flattening off that curve, back it down until you get that beautiful curve again. And then that's going to tell you your clean output.
I'm going to interrupt you real quick. Matt Stark has a question. If you're going to you can start, I can't start it from my end or else I would start. You mean one of these?
Oh, okay.
We'll talk about it later,
Matt.
We'll
get to that. Yeah, we'll talk about it later. So that's not the only thing you need, though. What's the other thing you need? Because that's only going to give us voltage, right? Justin?
Mm-hmm. Mm-hmm.
So Correct. We need amperage. So we need a clamp meter. You want to talk about the clamp meter?
I've never used a clamp meter before, but you set that on AC and you just put the wire through the clamp. And I think it's a Hall effect sensor in it is what it's called. And you just, it's designed for, if you've ever seen like a real electrician use one of these where they'll put a clamp on it at the meter box so they can measure power being pulled through a breaker. A million uses for that thing. You can pick them up anywhere. You got a Klein. Is that what you've got?
No, you know what? This is actually a Tac Life, but I recommend the Klein. You can buy a cheap one. A true RMS is the better route to go. Right. But yeah, you clamp it around the positive of the other side terminal. So if you have a left and a right, hook this up to the left, hook the other one up to the right, and then this will give you the amperage. You can hook them up to the same
channel, can't you?
You can. I mean, especially if you're doing a single channel, but it makes it easier to just get out of the way. And you want it as close to the amp as possible.
And what that's going to do is it's going to measure the amperes of current. And then your multimeter can measure the voltage. But you don't need an oscilloscope to measure the voltage, but you need the oscilloscope to see the waveform so you can find out where it clips.
Yep. And so it says right down here on the screen, it says VRMS, which is your voltage. Right. So whatever that number is, we'll take that and then we'll multiply that by the amperage that we find on here. Once again, both of them are set to AC. AC voltage and AC amperage. And once you get those two, you'll go ahead and multiply those together, and that will give you your clean output.
Excellent. If you want to share the screen real quick, I'm going to show you the dummy loads that I use. I've got 4 of the exact ones that you've got, Nick. And I've got these 4 right here. I'll just kind of explain the setup.
Small things. They're small.
So these terminals right here, I'm pointing my cursor to it. Not sure how visible it is, but these double ones off the side, I've got some of those small ones wired up to those. So if I'm testing a small 4-channel amp or a head unit or something, I've got 4 channels, 2 over here and 2 over here. So if maybe I had a 5-channel amp or something. Oh, hey, Edens. Thank you.
Thank you. And we're going to answer this right after Justin's done.
And right in the middle, I have these 4 set up right here. And what I've got them parallel. So each of these terminals here is a 2 ohm load. So when I test an 8 ohm, hang on, they're each, 2. So when I'm testing 4 ohms, I series these 2 terminals across the front. And then I just test one of them when I want to do a 2 ohm load. And then I parallel them across the front. And that's how I do my test. And I've got quite a few jumpers and stuff for plugging into my test equipment. And it looks like a big mass and tangle of wires when I'm doing it, but it gets the job done.
Excellent. And you can see you had the mega, those silver things they're laying in the back. Those are actually his resistors, and those are what, like 1,000 watt resistors or so?
They are 504 ohms.
500 watt 4 ohm. These little guys are technically 100 watts, which technically means they're probably like 30.
First time I used those was on the a Toto video that I did, and they got hot to the touch, beginning to smell the wood around them getting hot kind of stuff. So I wasn't happy with the amount of heat they dissipated. They got really hot really quick.
Yeah. And technically any of these resistors, should be mounted to aluminum to help dissipate. but we can mount it to MDF if we want. So Justin, let me ask you this question. All right, does an amplifier power? This is Eden's question. And Eden, first of all, thank you for the super chat. We really appreciate it. And guys, if you do have a specific question, this is the best way to get it answered. And even if you don't, we always appreciate super chats. It's a great way to let us know that this information is helpful to you. Does an amplifier's power and lack of distortion denote how good it sounds, or is there something more that is not measurable with an oscilloscope?
Yes and no. Stu, I think, has a good answer for this down in the comments. Those two factors are probably the biggest contributors. After that, it goes to topology and harmonics, reproduction. If an amplifier is playing cleanly and playing inside, not clipping, it should sound just fine. But what I've noticed is sometimes you can get dirty amplifiers. They do exist. For example, let me see if I can pull up another oscilloscope shot here. I had one a second ago that showed some pretty gnarly clipping here. Just give me a second. No, that wasn't it. Hang on, I had it just a second. Well, you can sometimes see the clipping in the waveform. And that's what I was going to point out, that every now and then you can see it's not clipped, but the waveform starts to get wonky. So if there's distortion popping in, you can see it before it starts to clip. So
a lot of
most amplifiers, if they're not clipping, are going to sound just fine. Some of them are dirty, and you can see the dirty wave in the waveform.
Unfortunately, a lot of the stuff that you would get into that would probably help us know whether it sounds good or bad is measurable by something significantly more expensive, like an audio precision, which neither Justin or I have. And that will actually show you how linear the amplifier is. So how linear the frequency response is, which can have an effect, obviously, especially if it's a class D with a bad output stage. That's going to show that on there. And then there's also the amount of distortion, and where that distortion is located can also make an effect as well. So, what's the noise floor? Those types of things. And those types of things are things that we're not going to be getting into with the cheap way of doing it. If you want to get into the more expensive way with the audio precision, then yeah, those things will help you. Most of the time, if you buy a pretty decent amp, it's going to sound pretty good. It's just a matter of knowing if it's really being honest with you or not.
All right. Do you see how the waveform, instead of being a nice up and down, goes up and then starts to slope down and then steepens off, does the top and the bottom? You could hear that. It was audible. And I've got another one of these amps. It's not a Dayton Audio, it's a LaPi, and it sounds terrible. And you can actually see a secondary wave riding on the main wave. Yeah. And so, I mean, that's what, when you're listening to FM radio, the FM is a carrier wave, and the music you're actually hearing is a wave riding on that wave, to really dramatically simplify things. And so sometimes there'll be like a noisy signal that you can actually see riding along the existing waveform.
And so it's crazy too. That's you're only at 2 volts RMS. If that's a 12 volt system, that's only like 24 watts. That's not much going on.
Right, this either. Was the all of these Max Android head units that I've tested, the amplifier section on them have been terrible. The RCAs are fine, but I would never use one of these as a head unit for music.
Yeah, most of them, it's good to have secondary. I mean, some of it depends on what you're using it for too. Daily drivers where you don't really turn it up that loud, it's like, as long as you're okay with it. But none of them are going to be great sounding. None of them are going to win any awards. Let's put it that way. And I think Eden's is right. A lot of head units seem to clip around 15 watts or thereafter. And so a head unit's another example. If you wanted to test the output on a head unit, you don't need to hook up. You need 4 of these resistors, right? 4 of these 4 ohm resistors. And they're not expensive. These resistors, these 100 watt resistors, I think I linked to them. They're like $10 for 10 of these. What a lot of people will do is they'll buy a bunch of 8 ohm ones, which is a better way to do it, is buy a bunch of 8 ohm ones and put them in series and parallel. So then you can get 4 ohm, 2 ohm, and 1 ohm, all kinds of loads, and still get more amperage. But I bought 4 of these 4 ohm just so I would have it to be able to do head units. But yeah, you should clamp everything down, even if you're not testing all of them, because that allows you to see how the power is actually truly being dissipated. Basically, test it how you're going to use it. If you're only going to be using a 4-channel and it's a 2-channel bridge, for example, then test it as at the bridge impedance that you're going to be testing it at, or using it at, period. Or if it's a 2-channel but you're only going to be using the 1-channel bridge, test it that way.
So tell me, Nick, how much money should you spend if you buy one of the inexpensive oscilloscopes and a halfway decent clamp meter? How much money does it take to actually have the tools you need to do a test with a load test like you've done on your last video?
So these are $10, right? So these aren't that bad. So $10 for the, for these little guys. They get hot. The oscilloscope, I think, went up to like 90. So you're looking at $100 there. And then I think for a cheap clamp meter, you're looking at about $30. For a more expensive one, you're looking at 80. So you're looking around 130, 180 bucks, which is not expensive, really, when you think about it.
So why would you want to spend more money for this?
I don't know. Why do you think so?
So a couple of things. First of all, it is the exact same thing. On this end, there's leads for a multimeter. So you can, and it has a clip light on it, so you know when it's clipping, right? And in the middle, that's the exact same thing as the clamp. It has a sensor that you run the wire through this, the speaker wire through that middle right there. And what this will do is it'll do the math for you. And my opinion is that the main advantage to this device when just doing a dummy load test on your bench is that this device will count up and do the math for you, and it makes for a more dramatic video.
Well, it's the only difference is that's about $500, right?
Maybe 400. I don't remember. It's been long enough since I bought it that I've forgotten how much I spent on it. So that's
so really, I mean, really, it's a good value if you're going to be doing a lot of it because it saves you a lot of time.
The other thing is that this right here will do something you can't do with your resistor or with your clamp meter and multimeter.
I'm listening.
You can't test a reactive load with that setup. You can only test a dummy load.
Well, you can test it. Are you talking about like music?
Right. So if you were to play a test tone through a subwoofer and put your setup on it, you would not get an accurate reading.
So first of all, we actually forgot to mention that part of the whole testing. You have to play a test tone through it for the testing portion. We should mention that. And if you're doing the testing with a test tone, full range is 1 kilohertz or 1,000 hertz. That's for a full range.
That's the standard, right, for a full range amp. Yeah.
And for a subwoofer, 50 hertz.
Or
some
40.
People do 40. Yeah, some people do 40. Yeah, 40 or 50.
But this one right here, you can play music through it and it'll give you real-time power while you're playing music. And when you're playing music, you end up with something a little bit different than when you're going into a resistor, because a resistor is just a resistor. Doesn't matter AC or DC, a resistor is the currents kind of sees that, not that current can see, and acts the same. And whenever you're dealing with AC current going through not a resistor, going through a capacitor or an inductor, you get this thing called power factor. And the way to think about it, Nick, you know this from dealing with crossovers. When you run current through a crossover, you get to be out of phase at the crossover point, right? That's why sometimes when you design a crossover, you flip the tweeter over so that you're in phase at the crossover point.
Correct. You have phasing that you have to work with. Yeah.
Right. So the phasing is the result of AC electricity. And basically what happens is the voltage and the amperage, so the voltage and the current, get out of phase with each other. They don't happen at the exact same time. So when the voltage is peaking, the amperage might be, well, worst case scenario, 180 degrees out of phase and at its lowest point, and you don't get any power because you have no amperage when you have voltage and vice versa. And anytime you run AC through a coil of wire, you have what's called an inductive load, and it's not the same thing as running through just a plain old resistor.
Gotcha.
Brian Steele has said it succinctly. It won't measure the phase difference. This will actually calculate the phase difference between the two. It's a power factor. You have to calculate the cosine of the slope of the difference between the two curves or something like that. So it's not something that's simple to do.
We're talking about a lot of curves today. My wife's going to get jealous. So I will tell you this. I honestly don't care because I'm never going to measure an amplifier playing music. So I don't technically care about that personally. I guess there might be some reason why you would want to do. I don't know. Is there a reason why you want to do it that way?
Because it makes for a good YouTube video to pump 1,000 watts through a 500 watt subwoofer and then catch it on this device right here.
Okay. Because I'm thinking like practicality. It doesn't. But there is some truth to this, right? Like when we're testing speakers impedance. So if it says a 4 ohm speaker, it's not 4 ohm flat. There are some drivers that are, but when we're talking subwoofers, which most people are talking about, normal speakers, the impedance goes up and down. So the truth of the matter is, when we talk about what an amplifier is capable of, that's really what we're talking about, what an amplifier is capable of, not necessarily what your speakers are seeing when you're giving it to them.
So what's going on here, we talked about this before, is that impedance is a function of the AC voltage. And so at different voltages, you're going to get different amounts of impedance going through an inductor. So, what do you actually get in an amplifier? You're not going to get the same amount of power as you would get through a 4 ohm resistor because your speakers aren't going to be playing at exactly 4 ohms all the time.
And the music's not going to be pushing it always at the same peak.
So the frequencies are going to vary at any given moment. And so, this is why you see some car audio people wiring their 1 ohm amp to a half an ohm. This is what they call box rise. The right name for it is impedance rise. It doesn't happen in a box. It just happens anytime you have an AC signal going through a coil.
All right, I haven't done this. Have you messed around with the power sensor on the SPL lab? Because you have one.
I have one. So
it has a built-in oscilloscope, THD meter, power, something.
So mine doesn't have that. Mine is the simplest, most straightforward version. And if you were to go to SPL Labs website, they have a version that allows you to wirelessly connect different modules. So you can put a clamp meter on, everything this will do, plus pick up the SPL at the exact same time and measure the voltage in your car at the exact same time. Multiple modules you can add in. So they've got a pretty well-developed system. And I think that, feature for car audio, I think price-wise, it's going to outperform this. But if they're more complicated as anything like this one right here, it's a pain in the rear to use. The owner's manual sucks. Hi-Fi Vega's got a video showing how to use this. Every time I dig it out, I have to go watch this video because it makes no sense. You've got 3 buttons that mean nothing, and I really don't like it because it's just too confusing to use. You would think 3 buttons would be easy.
And maybe I'm wrong, but it seems like that would be more useful in setting things up after they're already installed in a vehicle.
Well, this one right here is just designed to get an SPL reading.
No, I'm talking about this. Yeah, I'm talking about the system.
Right.
Though, yeah.
But the whole system together, again, it can do that plus a whole lot more. So it's a pretty versatile system. I haven't tried it yet. It might be on my list of things to do this coming year. So.
All right. So we spent about 40 minutes talking about amplifiers. I think we should talk a little bit about speakers before we do the whole show on amplifiers, and everyone that wants to come talk about speakers is left wanting more.
Before you do that, hit Brian Steele's comment.
All right, which one? This one right here?
Watts equals volts. Watts equals volts times amps times the cosine of phi. Cosine of phi is the power factor. Phi is the phase difference or something like that. Yes, that's about right. And before we move on from amplifiers, it's still general for speakers. I have a question for you, Nick.
So real quick, I thought he was talking about cosplay for a Greek fraternity or something. Good. What are you going to say?
See, every time that I talk about AC current coming out of an amplifier in a video, every time someone jumps in the comments and claims to be an expert and then tells me that I'm wrong, that the power coming out of an amplifier for car, home, whatever, is actually DC current.
Yeah, you know, okay. Have fun with it. I mean, who cares? I mean, there's no sense arguing with anyone about anything, in my opinion. So if they want to believe that, go right ahead. Let them test it with their DC meter and their DC oscilloscope, and then tell us what their findings are.
Yeah, Brian still says what?
Yeah.
They will usually
you know,
try to explain to me that it's a modulated DC.
I,
So they're
I would
using
say
a
this.
modulator in order to turn DC into AC. And it's like, that's still AC,
Oh,
buddy.
a rectifier, yeah. So I think the reason why is because you're hooking it up to DC power of some kind. So the assumption is typically that it's DC, and I can understand the confusion there. I think that, in my opinion, I think that's the most confusing part about doing this in general. Thank you, Jacob Travis. Jacob Travis sent a $10 super sticker. I was gonna say, I think that's the most confusing part in general is the fact that you have to make sure you get this set right, because a lot of people will look at that and say DC, that's not right, but it is.
So this is, you recognize this?
Yeah, it's a BMR.
Yeah. Okay. So, when the waveform goes negative, speaker goes in. When it goes positive, the speaker pushes out, right? It's an AC waveform.
Yeah, and he says it. Power going in might be DC, but not going out. And he's right. And it is what it is, Variable frequency and variable. Okay. So, all right, let's stop talking about amplifiers now. Let's move on to speakers for a little bit. So let's talk about what I think is the one measurement tool, besides maybe a multimeter, that every single person that's designing boxes, especially ported boxes, needs. And I would say every speaker builder in general. Wait, you have one? Wait.
I know what you're going to say.
We're going to put it up at the same time if I can find mine. Oh, wait, here it is. All right.
You know what we need to do? We need to start a drinking game. Every time someone on our stream says this, everyone takes a drink. Because you know what we're going to show. Wait. Okay, in the chat, if you know what we're about to show on we talked about it last week, put it up. And the week before.
Our guest talked about it. Who didn't? We had no idea we were going to talk about it.
We had no idea. You got to get one of these.
On the count of three. 1, 2, 3. What? Oh, yeah. there it is. The Dayton Audio DATS V3. Guys, this is we call this an impedance tester, but really that is not kind enough to this, because it's a lot more than an impedance tester, right?
We didn't talk before the stream, just so you know. We didn't.
No,
plan.
we didn't.
We didn't. We were like, hey, we should do the show. Okay, what do you want to do it on? Great. Let me go grab a box full of stuff so I can have props.
Let me grab that's exactly what I did. I grabbed the box full of stuff. This isn't my testing go bag, right? Like the Dayton Audio DATS V3. This thing is awesome. This thing has 2 power leads on it. Well, alligator clips, right? That you plug up to a speaker that's not plugged up to an amplifier. Don't plug it up to anything plugged up to an amplifier, because it'll backfeed your computer. Plug this up to a computer, and you can measure your impedance. And so if there's an impedance, like if we're doing a ported box and we want to make sure that we have it ported to the right frequency, what we'll do is we'll see 2 big peaks and then a valley in our impedance, right? So it'll be a big peak, another big peak, the 2 big humps, and whatever's in between those 2 big humps.
Yep.
That, whatever the lowest point is your tuning frequency. So that can give you your tuning frequency. What else can this do?
I'm going to see if I can find a picture of one of my DATs testing.
Careful with that verbiage. I know, I was thinking about that. Yeah, so WT3 is the same thing. WT3 is Woofer Tester 3. They had Woofer Tester 3 V2, and then they had DATS V2, DATS V3. We are going to talk about this in just a minute, but we got to get through this first. So I'll star your comment, because we are talking about that. So what this does, especially if you're designing, hold on, especially if you're designing a speaker. Yeah, there you go. That's it. Go ahead, Justin.
Yeah. Oh no, go ahead, talk. I was going to let you talk.
No, you do it. You talk about that.
All right, so this is a zoomed in view of the output from a DATS. Just so you know, this is, I think, from a passive radiator kicker box. And so when you do a sweep with a ported or a passive radiator, this is the impedance as a function of the frequency. So right here where I'm hovering the cursor is 200 hertz. The impedance drops around to about 100 or 90. Then it goes up and drops again. And this middle trough is what, Nick? You know what that is?
That's the tuning frequency.
That's the tuning frequency. How would it look different on a sealed enclosure, Nick?
There would be there would be one peak. One peak.
One peak.
One peak.
One peak. And that would be the equivalent of the tuning frequency of a sealed enclosure.
It's the free air resonance. Yeah.
What's the word? What is it called? FB, box frequency? There's a name
FB,
for it,
yeah.
and I'm blanking on it.
So that's your tuning frequency of your ported enclosure. And that's really important because a lot of times, unfortunately, the speakers you get, the TS parameters are not correct. And guess what? Dayton Audio DATs can do as well.
Measure the TS parameters.
It can measure the TS parameters. So if you have a woofer and you don't have the TS parameters and you want to build a box for it, you need a DATS V3. So if you're one of these people that likes to salvage around at people's like garage sales and stuff, buy things, and you might want to build the perfect box for it, DATS V3 does it. Basically, you just hook these up to the terminal of the speaker, right? A positive and negative of the speaker. Or if this is a subwoofer, unplug the amplifier and plug it up to the back of the subwoofer. The other thing that this can do that a lot of people don't know, I was talking to a guy on the phone today that has some very old speakers, and he's like, hey, they don't sound as good as they used to be. And I asked him, did you test your components yet? Your resistors, your inductors, your crossover? And he's like, no, this does that. It can test your resistors. It can test your inductors. It can test everything. So I actually, this is a funny story. So I'm working on finishing my perfect center channel, which is awesome, by the way. And I got everything glued in the box, got it out, ready to test like the final crossover. I used a different resistor than the one I tested with for various reasons. Brand new resistor though, brand new. And I turned on, I'm not getting any sound out of my tweeter area. I was like, what the heck? And I'm testing, so I keep testing and I'm like, I can't figure out what's going on. It's only working after the crossover and I'm like, something is going on. So I took this out and tested every component. My resistor was supposed to be around 5 ohms. Guess what it was actually reading? You're muted, so I can't hear a word you're saying. Stop with your mute button.
Sorry, I make a lot of weird noises and I mute myself so you can't hear them.
Wow.
You had a dead short.
It was 14,536 ohms or so. I was like, oh, like now I know why I'm not getting any sound out of this. So
that's a lot of resistance. It
was a lot of resistance. So we, I'm sure had a break or something, but
I've got something right here in my hand that you can't see. I've not held it to the camera yet. That I call it my bargain DATs. And for literally the price of nothing, junk you have laying around the house, you can get really, really close to finding your tuning frequency Justin, on a ported subwoofer enclosure.
Zoom in on that picture.
I think I'm zoomed in.
Mouse wheel, bud. Yeah, mouse wheel. Yeah, there you go. There you go. All right, now go ahead and say what you're saying.
So this is my budget. It won't do anything a DATS will do, but it will test your tuning frequency, and this is it right here.
Paper.
You know what to do with that?
Oh yeah.
You take that and you cut some strips in it, and you lay it in front of the port, and then you play various test tones, and you're looking for that point when the paper's going like mad and the cone's barely moving, and bam, you've got your frequency tester, your tuning frequency tester for virtually nothing.
Okay, so people ask some questions like, all right, what would, and you can do that a couple different ways. You can do it with rice. I showed it actually in a video on a passive radiator, how to test what your tuning frequency is, a passive radiator. You can do that a bunch of different ways, but that is a great way to do it. Test crossover. What we're talking about testing the crossover is testing each individual component to make sure that they're within spec of what you think they're supposed to be. So for example, if you have an old speaker and you look at a capacitor and maybe the capacitor is bulging, assuming you test it before it goes bad, it should give you the value of it. And so you can replace your resistors, your inductors, whatever. A lot of times they're written on there, but sometimes when they get so old, they're missing. So what we're going to do with it to test speakers, and I'm going to assume a completed system for right now, is you take this, you hook it up to the back leads of your speaker, and you run your impedance jig. It's going to give you something like what he said. And that impedance, you're going to see rise and fall. But the bottom part of wherever it is going to be what we consider your nominal impedance. So for example, for a 4 ohm load, it can be basically 20% under. So it can be 3.6 ohms or above, and then it can be considered a nominal 4 ohm load speaker. Anything like 8 ohms needs to be like, what is that, like 6.4 ohms. So as long as it's 6.4 ohms or above, we can consider that a nominal 8 ohm speaker. Somewhere in between is going to be a nominal 6 ohm. Okay, so that's how you're going to know what your speaker is. So that's going to give you your impedance, and that's really important. Someone had asked, why do I need to know about my tuning frequency? The reason why you need to know about your tuning frequency is, first of all, you need to know if your speaker you're having is considered full range or not. So anything tuned like 30 hertz or so, you'll be able to use probably full range with music without having to worry about putting a high pass on it, like you might need to worry about if you're doing like a surround sound system or something of that nature.
And if you're building a subwoofer, you usually have a tuning frequency you're shooting for, and you want to know if you missed it or not.
It's a great point. You have some pictures you want to show?
No, that's just the same one.
Same one. My bad. Now, the other thing that you need if you want to test speakers, we're going to assume you're going to want to test a frequency response. We've got about 10 minutes, so we'll try to do this fast, is this. Testing microphone. And I'm going to show you why you spend more money on the good microphone. Look at this. Da-da-da-da. Oh, carrying case. You don't got no carrying case with yours, do you?
Yeah, mine has a carrying case. The one I was going to show you.
What the heck is that thing?
That's the case for this guy.
Oh, the little Dayton. What is that, an old Altoids container?
It kind of looks like an Altoids container, doesn't it?
Yeah,
but it
probably
is
sardines.
It's the metal case that this came in.
Oh, it came in there?
Yeah. Oh. You don't have one of these?
No, I don't.
This was the first test microphone that I ever picked up, and because I was using a cell phone. So this plugs into a cell phone, and you can basically get a cheap RTA app, and you can do an RTA with this thing.
Okay, here's the interesting thing about that one, though. So whenever we're talking about testing frequency response of anything, we're talking about usually a calibrated microphone. So what does it mean to have a calibrated microphone?
Okay, that sounds complicated, but here's what you have to consider. This microphone right here is not linear, meaning, David K. David K. is bringing the rain. Thank you, David K.
Making it rain.
Yeah, y'all see if y'all can keep up with David K. None of you can match him, I bet.
We'll find out. Now, and guys, I really do appreciate that. Both of us do, because this type of information has taken us years to accumulate. So it's not, this is stuff that you probably won't find in just one spot ever again. And if you do, I hope you do, actually, because that's awesome.
All right,
back to the microphone.
There's nothing special about this. This doesn't do anything different than any microphone you could possibly imagine. But microphones, just like speakers, don't have. Hey, Baba!
Baba's
you throw the challenge out, and Baba's going to come in there and bring it home.
Yeah, Baba will knock you out with it. He will just take it on and knock you out. Baba with the other super chat. Thank you, Baba. Now he just doesn't want you to talk, I think.
Hey, if super chats get me to shut up, you can. That I remember years ago, I was one of those dueling piano bars, and they were.
Yes.
Someone had requested Rocky Top, and so they were playing Rocky Top over and over again until someone paid more than the person who originally requested Rocky Top.
That's a good idea.
Like, we're playing Rocky Top until someone pays us more.
And we'll say this right now. There's nothing necessarily special. So most people think the microphone itself has been created in a way that gives you the response to be flat, because that's what we want. We want to make sure it's flat. Man, get some. It doesn't want us to talk either. Thank you, get some. Get some with another super chat. But it's not the microphone.
Thank you for the
flat,
generosity, gentlemen. Thank you so much.
I like that. He's like, wait, did you say get some? Because here you go. Get some of that super chat. Okay, that was dumb, but I like it.
The microphones aren't special. They don't do anything that a regular microphone can't do.
But they come with a calibration file.
Right.
Which tells your system whether you're using Rue or I use the Dayton OmniMic, and so it uses the OmniMic software. You have to load that calibration file in, and it will correct for the errors of how that microphone actually measures. So
the way to think about it, if you are playing back frequencies through this speaker, and this speaker does a really good job of getting low for such a small driver, it is a little dusty. There's a big dip around 4,000 hertz with this one, and below 100 it starts trailing off. Well, the calibration file just jumps in and says, "Hey, it's just like a text file or a CSV file or an Excel file." It just simply says, "Hey, here's the frequency response, and we're going to go ahead and just multiply the number at 4,000 hertz by about 80 because we know this thing doesn't play at 80 properly." And similarly, it's trailing off by 50% by 50 hertz. So we're going to double the number at 50 hertz. Something like that is what it's doing. It's basically a multiplier going. It's a vector.
Yeah. And so just to clarify, what they've done is they've taken a measurement of this microphone's response. And they have said, look, this microphone actually plays 3 decibels hot at 1 kilohertz. So it's actually reading, like if he was going to take a measurement of that speaker, it's going to show an uptick at 1 kilohertz up 3 decibels. It's not really there. And so the calibration file basically has gone in there and said, okay, we know that this microphone typically plays 3 decibels higher at 1 kilohertz. So what we're going to do is we're going to take it down 3 decibels. So now when you measure it, you're getting an accurate reading. David K and Get Some. David K again with another drop. Thank you, David K. What Baba and Get Some said, keep it. And they both said, keep it going, guys. So I guess.
Hey, Star Marty Jr. 540's
That's
comment.
true.
I want to answer it before the day's over. And these things are all serialized, right? They all have a serial number, and there's mine partially covered up for this. And the UMIC has one. All these microphones have a serial number, and that calibration file is tied to that serial number. They actually test the individual microphones at the factory to get the calibration files.
Absolutely. And so David asks a really good question. Is the mic's response the same at very high and very low SPL levels? And the answer to that is maybe.
Ooh.
Now let me go ahead and answer why the answer is maybe. You have to get above your noise floor in your room. So whatever your noise floor in your room is, you have to get above that. After that, the answer is yes, up to a certain degree. So once you go over really 100 and some decibels or so, most measurement microphones aren't really designed to go that high. They're not SPL meters. They're not designed to go 110 decibels. So you could get variations. You can even damage your microphone by playing it too high of SPL applications. So that's why a lot of times when you see my measurements, they're around 80, 85 decibels. One, I care about my hearing. Two, I don't. But let's assume that you want to know the what's the word I'm looking for? The sensitivity of a speaker.
Right. And while you're digging that up, Baba, thank you again for another super chat. Gentlemen, thank you so much.
I missed it. Yes, thank you. We truly appreciate all this knowledge you share with us. Shout out to David K and my man Get Some. Seriously, you guys are awesome. We really appreciate that. This has been one of the best shows. So we're happy that you guys are enjoying measuring things because we like it. Well, I enjoy it. Justin didn't say anything.
Yeah. Oh, yeah.
So.
I just find Rue hard to use. Otherwise, it's fun.
I know. And guys, I'm going to be honest with you. If you're new to measurements and you don't want to learn a big old program, I would highly recommend the OmniMic. It does come with this nice little case and stuff, which, by the way, will save you a lot. It's a lot more expensive than a UMIC one. I put UMIC one in there. Dayton has some other ones. They're cheaper. This is definitely more expensive. You can use it with Rue. Someone asked me that question the other day on the website. You can use it with Rue, or you could use it with OmniMic software. Get Some again. Thank you, man. And I think we lost. Yeah.
Wow.
Word. So let's see what. So these I picked up from Goodwill for $4. So let's just say I wanted to know the sensitivity of this. What we're going to do is we're going to hook this up to an amplifier. And we're going to take our multimeter. We're going to put it on AC volts. And we're going to wait till it says 2.83 volts. We're going to turn the volume up so it says 2.83 volts. When it says 2.83 volts, then we're going to put this speaker 3 feet away from it. When we do that, we're going to measure the frequency response. It's going to give us a frequency response. When it does give us that frequency response at 2.83 volts, okay, then we'll know our sensitivity of that speaker. It'll be basically an average of where the response is. Unless you're Klipsch, and then it's wherever the peak is.
And the thing to remember about that, and Andy,
Live in Live with Andy, thank you so much. Yeah. Go ahead. You can
thank you, Andy. If you were to run this test on your channel, someone's going to jump in and say you did it wrong. The speaker's too close to the floor. You should do the test outside. You should do the test in one of those quiet rooms. What they call an aperiodic chamber, anechoic chamber. Guys, we are DIYers, and we aim our channel at other DIYers. No DIYer is going to have an anechoic chamber. These are all in-room responses.
Most speaker companies don't have an anechoic
right.
chamber.
And I mean, I forget the name of the guy. Impulse Audio for the longest time was doing these tests outside. If you're going to watch one of his videos, he puts a speaker up on a ladder. We had him on the show probably about a year ago, and you can take this to the most complicated level that you want, or you could just do it and say, yeah, I know that I may have had a room reflection. So what? I'm trying to have some fun with this. So don't get lost in the weeds when doing this testing. You don't have an anechoic chamber. You're not a giant company with a Klippel. You just have to make do with what you have.
And this is where the OmniMic comes in handy. The OmniMic actually can get rid of a lot of those room reflections. You can actually take your impulse, select it by showing that. We're not going to get into that today. And it'll remove most of that. And it's very, very accurate, showing you what your actual response is. But real quick, let me answer this. What exactly test tone do we do at 1 meter? You do the entire frequency response.
Do a sweep.
So you're going to do a frequency response sweep. So if you know, you don't have to go 20 hertz to 20 kilohertz necessarily. Like if you're doing a subwoofer, you can go 20 to 200. Or if you're doing a speaker that you know is no longer than 50, you can do 50 to 20 kilohertz. But you do a sweep, preferably 20 hertz or 20 kilohertz. It'll give you a diagram that shows you what the response is, the peaks, the valleys, etc. And it will list the SPL associated with that. So I should have a picture of that. Let me see if I can pull one up.
You keep talking while I dig one up.
Okay, he's going to put one. And what that's going to do is, what I like to do is take the middle portion of that, like cut it in half basically. And that's really where your sensitivity is. A lot of manufacturers just like to push that number a little bit bigger, so they'll pick the peak, and so they might have a peak that goes up 5 decibels somewhere, and they'll say, okay, this is now 105 decibels. It's like, no, it's not.
Yeah, I'm not finding it. It might be on a different machine.
David, thanks again. David gave us another super chat. Said thanks for the answer on linearity.
I'm not finding it. I upgraded computers since I last ran Room EQ Wizard, and so I'm not finding the picture. I thought I could get it real quick, but I don't have it handy. If I find it, I'll let you know, and we'll put it up.
Okay, and so that's going to be the basic premise. Now, a lot of people aren't going to use the OmniMic. So how do we test high frequency and low frequency? Because the issue is, how are you going to get an accurate response? Most of the time, we don't really care about SPL. You can get an SPL reading if you want to, like for a manufacturer speaker. But then I recommend redoing the frequency response if you're using RU especially. Because what you're going to do then is bring the mic much, much closer to the speaker. You're going to put it at tweeter level. And by the way, all of these should be at tweeter level. All these responses should be at tweeter level, or wherever you think you're going to be sitting at the speaker. But most people put tweeter ear level. So tweeter level, I'll take this off so you can see. Oh, this is upside down. So you're going to put it at tweeter level. And I like to do about 16 inches away. At about 16 inches away, typically everything from 500 hertz on up is going to be a good measurement. So you're going to measure that, and you'll get everything from 500 hertz on, and it'll show you what your response is. So 500 hertz on up is good. Then what you're going to have to do is take a close mic measurement of your woofer. You have to bring the microphone right up to the woofer and take a close mic measurement, and then you'll have to splice that in later for 500 hertz and below. And one last thing that you might have to do, depending on if it's a ported speaker or not, you might have to take a measurement of the port itself as well, and then splice that in. So it's not necessarily an easy process. And this is once again where I think the Omni mic can save you a lot of time and money and hassle. It's kind of like the AMM1 you were showing. Like it's more expensive, but it also saves you time. So it depends on how much you're doing, right? If you're doing one or two responses, like who cares? Just do whatever you want. But otherwise, I like the Omni mic. And no one's going to talk me out of this. I use Rue sometimes. Well, actually, I haven't used Rue in like 4 years, but because haven't had to. But
And that's absolutely true when it comes to using any of these measurement tools. A lot of times, the better tool is faster or easier to replicate, and that's what makes it a better tool. You can use one of those oscilloscopes to set your gains. It does just fine. You can clearly see when it clips. You can use one of the SMD devices. They're going to show clipping at about the same time, and every amplifier with a clip light that I've tested so far are within a little tick or two on the potentiometer for the gain apart from each other. So, and thank you, Brian.
Thank you, Brian Rollerson. Yeah, we were just talking before the show, so I appreciate that, Jason. Brian, I'm sorry. Thanks for investing your time and knowledge in us. We all appreciate it. Brian's one of my patrons, and we talk occasionally about all kinds of cool things. We were talking about train wrecks today, I think. I was talking about how this lady got handcuffed by a police officer, thrown in the back, and they left her on the train tracks, and she got hit by a train in the cop car.
Oh my Lord!
Yeah, it's
where?
There's a lawsuit. In a cop car on the train tracks.
Okay, like no, what state?
I don't remember.
Wow.
I think
there
it
ought to be a lawsuit.
Yeah.
That's insane.
Yeah, she got really, really hurt. It was awful.
I mean,
someone else might
she
know.
was wrecked.
Yeah, she was wrecked, literally, by a train. Ever tried the transfer function method to estimate the bass? We should talk about bass response. How do you test subwoofer? Because here's the deal. Once you put a subwoofer in a room, you're testing, and this is the one thing. So if you're testing a subwoofer inside a room and you test like at your main listening position, you aren't really testing the subwoofer. You're testing your room. If you're testing the subwoofer and you're testing it in your car, you're not testing the response once again so much of the subwoofer. You're testing the response in the room. And so my favorite way to test a subwoofer, there's quite a few different ways. You can lug it outside and do a ground plane measurement, which basically you take your measurement microphone, you stick it far on the ground, and you tilt the subwoofer towards the ground, and you take a measurement. You can do that. Most people aren't going to do that because it's a pain to move your subwoofer in and out, especially if it's a big subwoofer, which most subwoofers are getting big now. So for me, close mic measurement is the best way to do it. The closer you can get your microphone to the subwoofer, the less of the room's going to be in there, right? So you get it as close to the cone as possible, shoot that microphone in there, and then if you need to, if it's ported, you're also going to take one of the port, and then you'll merge the two graphs together.
I've never done anything more than just using the mini SPL meter and just listening, right, enjoying it. Does it sound good or not? And that's one thing for sure. All this test equipment is fantastic, but if it doesn't sound good, then something's wrong.
That's a good point. I like that. If it doesn't sound good, something's wrong.
And one thing too that you've got to consider about testing, as I've been testing amplifiers and setting up systems and stuff, I began to notice when I first started doing this, I couldn't tell when distortion started just by listening. And it wasn't that I couldn't tell that it sounded bad. It was that I didn't know that it was distortion that I was hearing. Yeah. And now when I hook up one of these things and turn up till the clip light comes on, usually right before the light comes on, I start thinking, this doesn't sound good. And there goes the light. And it's all like, aha, I thought so. So after a while, as I say, back in the old day, people set everything up by ear, right? Old car stereo shops was all done by ear. How they do it by ear? Well, they just did a whole lot and listened. And the important thing is training your ear. And if nothing else, having the test equipment makes it easier to train your ear, because then you know, hey, the light's on. Let me listen and see if I can figure out why the light's on.
Absolutely. And here's an interesting way to put it. So Earl Geddes is a famous. He does a lot for the audio industry, but he used to work for Ford, and he once had an amplifier and a car system sounding so good. There was like no distortion in it, right? At all. And they did a test on what people thought of the system. It was one of the cleanest. It was the cleanest system I think he said he'd ever made for a vehicle. And they made it, and they had people do tests on it, and everyone said, I don't like it. And they said, well, why don't you like it? And they said, it doesn't get loud enough. And the problem is, it actually got very loud, probably louder than most normal car things. But the problem is, a lot of times, we don't realize it's loud until we hear the distortion. And then when we hear the distortion, we're like, ow, that hurts my ears. When I made the Soundstage 15s, I made them, and I sent them to a guy, one of my patrons, and he built them and designed and loved them. And he said, the thing that I couldn't believe about them is they're so distortion-free speakers that he said, I turned them up so loud. He said, I didn't realize how loud they were until I tried to talk to the person next to me. Oh, here's Stu. Look what Stu says. You're on mute, I think, Justin.
Yeah.
Yeah. Stu said that's my customers. I do the same, and you're right. Unfortunately, that's the way it is. Until you hear distortion, sometimes you just don't realize it's loud. It's crazy.
So, BB Photo had a comment that said that the old Auto Sound 2000 test CDs had tracks to train your ears, and so would love to get my hand on some of those old Auto Sound 2000 test CDs. That's cool stuff.
Harman has always been one of those like industry leaders with that type of stuff.
I mean, for a while, one of the guys who are known for the old small parameters, I think it was Small, actually worked for Harman. And the Auto Sound 2000, that CD was created by the guy who had the Buick Grand National back in the 80s and 90s that won every car audio sound quality contest ever, year after year kind of thing.
So, yeah, that's interesting to say. Harman also, and this is one thing that you can think about if you want to or not, Harman will also talk to you about how to listen to speakers to know how they sound. And the best way, and not everyone agrees with this, by the way, but what they tell you to is to do this. Listen to one speaker at a time. Every time
just the tweeter, just the tweeter, just the woofer, or just like
no, just one whole unit. So like not a stereo pair, just a single speaker. Listen to one of them, see what it sounds like, and then go from there. Because every time we add another speaker to the system, it makes it harder and harder for us to hear the differences in the speakers. And so listening to one speaker mono is supposed to be the best way to do that. This is what speakers. This is a Mirage AVS 200. I picked it up for $4 at. I picked up 4 of them for like $4 at Goodwill.
Goodwill. Yeah. Is that the brand sounds familiar? Are they any good? What's that?
Yeah, Mirage used to make some high-end speakers.
Gotcha. So this here is the Dayton Audio RSS 265-H044. This is the reference series HO, the high output version. So they have 3 different versions of this reference series. They have the HF, the high fidelity, this one, the HO, and then they have a new one, the high excursion, the HE. And I bought this, and I've not done a thing with it. I need to build a box for it. One of my goals is to have this thing in an enclosure this summer. One reason why I bought it was because I was told it did really well in small sealed enclosures, and that this thing was so low distortion that a lot of people didn't like it because they were so used to distorted bass that when this thing cranks up, they're all like, hey, where's the bass? It's like, no, it's making a ton of bass and it sounds fantastic. You just love distortion. And I'm excited to
Yeah.
try it out and see if it actually is
And
as
there's a
good as
lot
they
of
say it is.
there's a lot of truth to that, and that's what I love about the 21s that I built recently is because you don't even necessarily hear the subwoofers going, you just feel them, right? And that's like the cool part for me. Like I want to get that feeling. I don't want to hear bass that's like that sounds sloppy and muddy and over. Like I just want to feel it.
Right. You don't want to hear the speaker, you don't want to hear the port. You just want to actually hear the music.
I'd rather not. Yes. All right, guys, we have been doing this for almost an hour and 20 minutes, which is an hour and 15 minutes, longer than what we used to. I didn't get to talk as much about the home audio side of that. So if you guys want us to do another one sometime on more home audio testing, we can get some more pictures and stuff ready for you guys. You can just tell us if that's what you want to do. But before we go, we always do one thing that tells kind of behind the scenes, where you guys get some behind the scenes footage of what we're going to do next. You'll get to find out before everyone else. And so I want to know, Justin, because I don't know, what do you have going on? Because I'm interested.
Oh, you would ask. Give me just a second if I can find them. Where? Oh, yeah, I'm working on some behind the scenes stuff here.
Oh, and guys, if you found this information useful while Justin's doing that, make sure to please like the video, subscribe to both of our channels if you haven't already, and feel free to share this with friends that might need it. You know, like, some people need to know about the curves and the flat spots. Okay, what? Oh, wait, Nick, I found some spare mids for those old. Oh, awesome! I want to see that.
All right. You can put up the picture now. This is what I'm working on behind the scenes. My patrons have already seen some pictures of this. So this is a just a box to hold my amplifiers, just to organize them a little bit more clean. So I've got some amplifiers coming together to throw them in the truck and hopefully build more of a platform for testing speakers. My goal for this year is to build something that I can use to do more, hey, let's throw a subwoofer in a box and test it out kind of thing. So slowly working my way towards this little project right here. And as soon as I get done here with y'all, I'm going out to the garage and trying to make this look a little bit nicer and a little bit cleaner. So
that's going to be nice. I'm looking forward to that. That is a lot of stuff. I just actually heard about Down for Sound coming out with this ridiculously huge, what is it, like 7,000 watt amplifier or something crazy.
They've got several. My goal is to buy everything they make that's in this color blue. And so when they figure that out, they're going to keep making more amplifiers just to sell them to me.
So interesting that Brian Steele has talked about this. I haven't yet, but I would like to do a video about 3D printing speaker boxes from design to actual big. I think that'd be cool. I have 4 3D printers right now. I might be getting some more. So I think I will probably do a video on that. I'm a big advocate of using new technology while we have it. It's really cheap and anyone can put a 3D printer around, right? Like 3D printers now, like not this one, the one in the other room, I think was $180 and it's great. And I mean, what's filament like $20 or something? And you can build like 4 or 5 boxes with that. I mean, I wouldn't necessarily use it for a subwoofer, but you know, for other things, that's kind of nice. Oh
yeah.
So I have a couple things that I want to put out this week if I can. One of the first thing that I really like to put out is I had to sell my record player when I moved here because I was afraid it wouldn't make it. Like I was afraid it would get damaged. And that truck was so full. We moved from Pennsylvania down to Tennessee. We had 1 truckload. Some things had to go. I gave it to a friend who always wanted one. I was like, oh, I'll just pick one up. I never bought one until now. Now I have one. It's a Retro Life. I'd like to review that. It's pretty cool too because this thing like does USB on the back, so you can hook it up to a computer, so you can take your records and restore them on there.
Oh, cool!
It has Bluetooth on it, so you can Bluetooth speakers too. I mean, it's if I remember correctly, it's got all the new technology, but it looks nice too. It has a weighted arm on it so that you can change how it lays on your records. I mean, it really is nice, and it is budget friendly, which to me is a huge deal. I like that. Now, the other thing is I have been working behind the scenes, and most of you guys know this, on what I consider the perfect center channel. I had some issues with this build. Mistakes were made on this build. They were crossover, especially, we designed the crossover on Patreon. I didn't have the parts in. I had to order them in. Then when I ordered them in, I found out the parts were wrong because I made a mistake. So even I make mistakes measuring occasionally. And this is a very rare reason. The reason why I made the mistake is a rarity in general. But my patrons and I got a good laugh out of it. We got it behind the scenes on that, and we kind of worked through that. It was kind of cool. BB Photo, I don't have all those answers right now, but I'll have to say it. I'll have to figure that out. I'll know in the video. I'll give you all the answers to the cartridge and stylus in the video. I don't remember right off the top of my head, but it's very nicely made. They did a really good job with it. It's much nicer than the one I got rid of, so I'm happy with that. Or I gave away, I should say. So, but this perfect center channel speaker, if you've ever listened to a center channel speaker and sat on the side and said, I can't really understand what's being said, or can you turn it up, or whatever, you're going to want to watch this video, because we've come up with a way with certain drivers to use in a way that we don't get that off-axis lobing that you typically get with a center channel. So you can sit virtually anywhere and get virtually the exact same sound as sitting right in front of it. And I think this is going to change the way a lot of people listening to movies. And it's small. It's like not even 12 inches wide by like 5 3/4 inches tall. It is small. Like you can anyone can use this thing. It's pretty cool.
You got any pictures?
Yes. Oh, you know what? I think I have one on Facebook. Let me pull it up real quick.
Because I know I've seen a picture of it. And
I did. I know. I put them all over the place, but I can't remember where the heck I put them. By the way, guys, I have a Facebook account, Toyd's DIY Audio, on Facebook. So if you want to add me as a friend, you're welcome to. And
Andy's asking for a 2-hour stream. We've already done that. We did that last week.
Last week, right? Yeah. You know what? I can't find them right now, so you're just going to have to trust me. Actually, there might even be some on YouTube, but you'll just have to trust me. I have posted them places, but it's really cool. Is this Synergy horn style? No, I'm telling you, this is small, tiny, like real small speaker. It's pretty cool. Perfect. I need a center channel to make for my parents. Yes. Edens, you're absolutely right. And this is the problem with 98% of center channels. They're designed to fit in a cabinet, right? Like they're designed to fit underneath a TV, which is what you need to do. But they're designed incorrectly because once you put it on the side, you can't hear left and right side. And that's exactly what this is designed for. And I got to be honest, I'm really excited about this. I think this could be a really big deal. Nick Stocksby on Facebook DM'd me at 3 a.m. I did not.
We need to have you on the show sometime. I'd love to just go through your catalog of stuff that you've built. So
that would be great, actually. Yeah, I would like to.
Yeah, Stu makes good stuff.
All right, guys. Well, we are out. We are gone. It's an hour and 22 minutes, man. I have really enjoyed this episode, so we'll see you guys later. Don't forget to comment on the video. Talk to you guys later.